Hello and welcome back again to lecture 5, Organic Molecules and Structures. Please subscribe, comment, like, and share on my YouTube channel. Today, we will talk about degree of unsaturation or index of hydrogen deficiency. Saturation and unsaturation. Saturated organic compounds are those with only one carbon-carbon or carbon heteroatom single bond. Saturated compounds contain the highest amount of hydrogen atom, which is possible, and then with no double bond or triple bond, carbon-carbon or carbon heteroatom bond. Saturated molecules do not contain rings also. So this is an example of a saturated molecule. If you look at each bond, we can see a single bond between carbon-carbon or carbon-hydrogen or carbon heteroatoms. The same thing applies to this. We have carbon-carbon bonds, no double bond or no triple bond. Unsaturated organic compounds are those with at least one carbon-carbon multiple bonds or carbon heteroatoms multiple bond. The multiple bond could be a double or triple bond. They may include rings as part of their structure too. So an example is given. We have this structure. We have a carbon-carbon double bond here. We have carbon-carbon double bond here. And then the second structure, we have carbon-carbon triple bond. And then here we can see carbon-oxygen double bond. And then this one, benzene, we can see alkene functional group, that's double bond, alternating. And then unsaturated, according to the definition, it can be a ring. So this is an example of ring structure, that's cyclohexane. So this is also unsaturated. Degree of unsaturation. Hydrogen atom with a single bond have a DOU, which is degree of unsaturation of 0, indicating that they are saturated. Specifically, for every carbon in a saturated molecule, there will be twice as many hydrogen plus 2. That's saturated hydrocarbon molecule. They have the formula CnH2n plus 2, where N is the number of carbons. Alkenes are referred to as hydrogen saturated because they contain the most hydrogen atoms. Hydrocarbons with a single carbon-carbon double bond or a single ring are considered to have a single level of unsaturation. This is because adding a ring or a double bond necessitates the removal of 2 hydrogen, yielding the formula CnH2n. This is an alkene. Hydrocarbon with 2 double bonds, 2 rings, or 3 bonds are considered to have 2 degrees of unsaturation. A compound with 2 degrees of unsaturation may contain a double bond and a ring. Compound with 2 degrees of unsaturation will have the formula CnH2n minus 2. Calculating degree of unsaturation using a formula. The degree of unsaturation, DOU, is also known as the index of hydrogen deficiency, IHD, or ring plus multiple bonds. And then it is used in organic chemistry to represent chemical structures. The formula for degree of unsaturation is 2C plus 2 plus N minus S minus H all over 2, where C is the number of carbon atoms, N is the number of hydrogen atoms, S is the number of halogens, and then halogens that's fluorine, chlorine, bromine, iodine, and etc. And H is the number of hydrogen atoms. Note that oxygen or sulfur atoms do not affect the relation in calculating the DOU. The formula specifies the number of rings, double bonds, and triple bonds in the compound to be drawn, but does not provide an exact number. Inspection and other analytical techniques are used to verify the final structure, like NMR spectrometry. The degree of unsaturation is used to calculate the number of rings plus multiple bonds, where a ring counts as 1 degree of unsaturation. A double bond represents 1 degree of unsaturation. A triple bond represents 2 degrees of unsaturation. So if you do your calculation and get DOU of 1, that compound may contain whether a ring or a double bond. But if DOU is 2, it may contain 1 triple bond. The charts below clearly illustrate the various combinations of double bonds, triple bonds, and or ring for a given degree of unsaturation. Each row represents a different combination. For this table, we have DOU to be this column, and then possible combination of rings or bonds in this column. And then we have our number of rings, number of double bonds, number of triple bonds. So if you calculate DOU and then DOU is equal to 1, the possibilities are if whether we will get 1 ring or 1 double bond. And then the compound will not contain any triple bond. So here's supposed to be 1. Yeah. And then if you do your calculation and then DOU is equal to 2, the possibilities are whether it may contain 2 rings or 2 double bond or 1 triple bond. It can be in a situation that if DOU is equal to 2, it may contain one ring and then 1 double bond. Remember that the degree of unsaturation only represents the sum of double bonds, triple bond, and or ring. For example, the degree of unsaturation of 3 can have 3 rings, 2 rings plus 1 double bond, 1 ring plus 2 double bonds, 1 ring plus 3 triple plus 1 triple bond, or 1 double bond plus 1 triple bond, or 3 double bonds. Example: determine the degree of unsaturation in the following molecules and suggest possible structures for each molecule. Example 1. We have C3H8C2H2. So number of carbons here, our number of carbons are 3 plus 2, which is 5. Number of hydrogens are 8 plus 2, which is 10. So our total number of hydrogen are 10, and then carbon is 5. So from DOU, degree of unsaturation, DOU is equal to 2C plus 2 plus N minus S minus H all over 2. That's our formula for DOU. And then again, we can, our number of carbons, 5 plus 2. There's no hydrogen, there's no nitrogen, so plus 0. There's no halogen, plus minus 0. And then hydrogen is 10 all over 2. Here, we can cancel this. Sorry. 10. We have 2 times 5 is 10 plus 2 minus 10 all over 2. Again, this 12 minus 10 over 2. It is giving us, we have 2 out of 2. So our DOU is 1. So our possible structure is that possible structures. The compound, might contain either a ring or a double bond. That's our final answer. And then for the C4H11N, our formula for this one, our formula is 2C, the same thing. So number of, so our DOU will be equal to 2 times 4, because number of carbons are 4, plus 2, plus number of nitrogen is 1, minus 0 minus hydrogen is 11 all over 2. So 2 times 4 is 8. 8 plus 2 is 10. 10 plus 1 minus 11 all over 2. So here we can have 11 minus 11 all over 2, which is 0. So for this compound, it contains a single bond because our DOU is equal to 0. For the third structure, our number of carbon is 6 and hydrogen is also 6. So 2 times 6 plus 2 plus 0 minus 0 minus 6 all over 2. So 2 times 6 is 12 plus 2, 14 minus 6 all over 2. 14 minus 6 all over 2. So this one is 8 over 2. And then our DOU is 4. If DOU is equal to 4, we might get 3 double bond. Double bond and 1 ring, which is likely to be benzene. And then we can also get 2 triple bond. So that's our possible structures. For the fourth one, we have 2 This is because oxygen atom is omitted. It doesn't form part of the DOU formula. So our formula is 2 times the number of carbon, which is 2 plus 2 minus no nitrogen, and then no halogen, and then we have number of hydrogen is 4. So 2 times 2 plus 2 minus 0 minus 0 minus 4 all over 2. So we will have 2 times 2 is 4 plus 2 6. So 6 minus 4 all over 2. We will get 2 out of 2, which is equal to 1. So our possible structures are the molecule can contain a ring, or a double bond. For the last molecule, that we have a number of carbon. C is equal to 2, H is equal to 6. Oxygen doesn't form part of the formula, so 2C plus 2 from our DOU, which is equal to 2C plus 2 plus N minus X minus H all over 2. 2 times number of carbon is 2 plus 2 plus no nitrogen, no halogen, and then minus 6 number of hydrogen atoms all over 2. 2 times 2, 4 plus 2, 6. So 6 minus 6 all over 2, which is 0. So this contains only a single bond. Thank you. This is the end of lecture 5. Thank you for subscribing to my YouTube channel.